right, gang, let's first start with using sigma. So let me just make up something like really basic, just so we can take a look at it. I goes from 1 to 5 of I squared. Okay, so what this would mean if you did it by hand is that means that your I value goes from 1 to 5 and it goes into this function, and then sigma says add it. All right, so let's try that. So like, first of all, I would be 1. You'd plug I into the function. So you'd say, okay, 1 is squared. And then sigma says you add it to the next one. So now that means that I let I be 2. You put it into the function. You say 2 squared. And then you add the next one. So we keep going. So now I is 3. Put it into the function. 3 squared. We keep going. Say I is 4. So 4 squared. And then we get up to I is 5, where you have the 5 squared. So I went from 1 to 5, and in the function of I squared, this is the function you plug it in, the thing right here, and then sigma says add them all together. Okay, so 1 squared is 1, 2 squared is 4, 3 squared is 9, this is 16, and this is 25. All right, so what do we got here? This is 20, this is 30, this is 55. All right, so that means when I add this all together, when I actually just crunch it out by hand, it's 55. All right, so that's how sigma works. This is telling you where it starts, where it stops, what function it goes in, and then you're adding it together. Now over here, these are what's called summation formulas. Now there is a ton of summation formulas. This is just an example of 4. We're going to keep this very like basic, so we're just going to use these 4. So what I want you to do is recognize that I just picked this one right here, number 3. And what the summation formula is, it does what sigma does without having to do all the iteration. Like it goes right to the final answer. And that's good, because what if I had gone from 1 to 100, right? I would have been here for a while going from 1 to 100, adding that up. So what the formula does is it lets you just go right to the final answer. So let's check that out so you can understand what this does. All right, so in the scenario I did, n goes to 5. In the scenario I did, n goes to 5. My n is 5. My function is the I squared, which is why I picked this. And so now I'm going to solve this the same way I just did it, except I'm going to plug in my n as 5. So here I go, n is 5. So 5 plus 1, 2 times 5 plus 1 over 6. All right, so 5 plus 1 is 6. You want to do what's inside the parentheses first, right? 2 times 5 is 10, then I add 1. So this is 11, and this is all over 6. I'm just going to reduce the 6's, and then 5 times 11 is 55. So this says if I iterate from 1 to 5 on this function, it should output a 55. And it did, right? Because that's what we got. All right, so that is the idea. I just wanted to give you like a concrete example, because what you're going to see me do is going to get a little bit abstract. I'll do 1 or 2 that is exact, but they will get abstract after a while. All right, so let me show you how to, like, to go to 1 to 15 on this problem would take me a while, right? I'd do 2 times 1 minus 3, then 2 times 2 minus 3, then 2 times 3 minus 3, 2 times 4 minus 3, on and on, right? That would take me a while to do, but I can use these summation formulas to do that very quickly. So let me show you how that works. All right, now I will add a little more detail here to help you if you're sort of having trouble with this. The general idea is that you want one summation per term. One summation per term. So this is 2 terms, which means I'm going to be using 2 summations. So you want to go as high down the list as you can go. Like, is it an I third? Is it an I squared? Is it an I? Is it a constant? Don't start here and go this way. Start here and go this way. So this, the highest this classifies as is an I. Yeah, I know it's being multiplied by 2, but it's an I. So when I think about it in terms of summation formulas, sometimes my hand and my brain don't want to work at the same time. So when I think about this into summation formulas, is I'm thinking, okay, it's an I, but whatever the answer is, it's going to be 2 times larger. That's how I want to see this. It's 2 times whatever the I is going to give me. And then over here, all I have is a constant. I have to make sure that I subtract. So I'm trying to really break this down for you so you can see how this works. So this is an I. I'm going to do the summation on the I. The answer is twice as large. Then I have to subtract what the iteration of this constant 15 times. So for the I, you want to go to the I formula. N times n plus 1 over 2. I'm just going to write it right underneath it. N plus 1 over 2. That would be the formula for the summation on this guy. The constant is the constant times n. All right, I just wrote them like tiny little notes underneath. So here we go. Let's crunch it out. So for the first one, you have to make sure it's multiplied by 2. N here is 15. So you're going to have 15 times 15 plus 1 all over 2. 15 times 15 plus 1 all over 2. That's the first part. Then I have to subtract. Remember, I wrote the little formula here. The constant here is a 3. I have it n times. N again is 15. All right, so now you want to do the math on this. This is being multiplied times this, so I can just cross out the 2. So this is 15 times 16 minus 45. Because you're gonna combine this to make a 16. 15 times 16 minus 45. 15 times 16 minus 45 is 195. So this will iterate out to be 195. Again, if you wrote each little step by hand and then added it all together, it'd be 195. I feel like I can sort of hear some questions coming, so let me just answer them. I'm going to keep it very much to the rule book here, but yes, you can change these numbers around right, this can be fiddled with. We're not going to fiddle with it. I'm going to just give it exactly as I'm showing it. All right, I just feel like if anybody wants a second example of this, I want to help you see it. So I'm going to do this guy down here now. So I equals 1 to 10 of I squared minus 1. So again, make sure when you try to figure out which one you're going to use, you start from the highest to the lowest. All right, so the first one's an I squared, so I want to use this guy here. I'm really going to just break it down for those people who feel like they just want to see it really broken down. All right, so this would be the iteration for the I squared. Remember, 1 sigma per term. So if I have 3 terms, I have 3 sigmas. And then 1 iteration for the other term. All right, so now I squared is this here. So let's write that down. That's n plus 1, 2n plus 1 over 6. And then the 1 would be a constant. There's no I there, so you have to go all the way to the top. That's c times n. All right, then you want to plug into the formula. So n here is 10. So we're going to do 10 plus 1, 2 times 10 plus 1 over 6. And then for this one, we just need the constant here is a 1 and n is 10 again. All right, so it's 10 times 10 plus 1 is 11 2 times 10 is 20, then you have to add 1, so it's 21 over 6 minus 10. If you want to do some reducing here, you can. Like my brain wants to. I want to do like a 2 from here, a 3 from here. Not everybody's like my brain, but so if you have a calculator out, you can crunch this just as is. My brain likes to reduce things. So 6 divided by 2 is 3. I'm going to reduce it with this. And then 3 divided by 21 is 7. I just like things in a smaller form. All right, 5 times 11 times 7 minus 10 is 375. Okay, so this would iterate out to be 375. All right, gang, that's the part on the iterations. Let me end that concept here. Hopefully you got it. Catch you. Bye-bye.